Hey guys, this is a video on how to use Snell's Law to calculate the index of refraction, that's n, for a unknown substance. And then you could use the chart above to match the number you get for index refraction with whatever that substance is. So we're going to do number 1 here. It says light moves from air into an unknown substance below. Calculate the index of refraction of the unknown substance, then identify the substance using the chart above. Alright, so we said I drew a little dot to show myself where the light starts. As you can see, the arrow is heading down, and it heads further down away from that dot once it goes into the unknown substance. Alright, this dotted line is my normal line, and this solid line, I'm going to label it my interface. That's the barrier between the air and my unknown substance. Okay, so the light starts up here, all right, and we're going to use Snell's Law, which is an equation, to calculate the n down here, all right? All right, Snell's Law, I want you to write it down and box it. Right up in the top right of your worksheet, okay? You can zoom into it right here. Snell's Law is n1 sine theta 1, so that's sine, like the trigonometry function. N1 sine theta 1 equals n2 sine theta 2. All right, so write that down, box it. You could pause the video to do that now, and then restart it. We'll use it to do the problem below. All right, so now we've restarted the video. All right, and we're going to use Snell's Law and find out how to fill it in.
Nicole Alvarado, General Office. Nicole Alvarado, General Office.
Okay, so I wrote down Snell's Law right there, and we just have to figure out what to plug in to solve, all right? Our unknown substance, where the light goes into, is going to be N2. That's going to be our unknown. We're going to be trying to solve for that in the equation, all right? So N1 will be for air. All right, if we go to the chart above, the index of refraction for air is 1. So that means N1 is going to be equal to 1. So you got one missing n, that's n2, and one n that you know. All right. Now in the equation, we'll plug both n's in, but we also need both angles. All right. Those angles are measured with the normal line. That means that this solid line right here should be on the normal line when you measure your angles. All right. So let's measure the angle above the interface first. You should be doing this with your own protractor now. Okay, so if you're at the normal line, it should say 0, and you go over, and then it'll say about 56 degrees is what I'm getting. All right, and now is that theta 1 or is that theta 2? All right, well, the air, it was n1, so this is going to be theta 1. Okay. And then you had your protractor like that. You could just flip it over the other side to get theta 2. Now 0 is still going to be on the normal line. Down here it'll say 180 on the normal line. Alright, and then you could go over from 0, 10, 20, 30, about to 34 is what I'm getting. And because that's next to N2, that's going to be theta 2, 34 degrees. All right, now it's time to plug in. N1 was 1 for air. All right, sine theta 1. Theta 1 was also for air, 56 degrees. And N2 was our unknown, we're looking for that. And then sine theta 2 will be sine of 34 degrees, okay? Now the next step is to find the sine of whatever angle that is on your calculator. So you just want to type in sine of 56 using parentheses on your calculator. I'm going to do that right here on my calculator. Okay, so I get 1 times 0.829 equals N2. I'm going to do sine of 34 as well. on my calculator. And that gets me 0.56. 1 times 0.892 is just 0.829 is just 0.829 equals N2 times 0.56. And you could divide both sides by 0.56. And N2 is 1.48. Now, that number might not be exactly on the chart, but match it with the number that is closest. Looks like table salt is my closest number to 1.48. So I'm going to say that my unknown substance is table salt. And then once I've identified that, I've solved my problem. All right? That's how you do it.